Has anyone of you heard about the OpenSSL Debian bug? Sorry about our English. We know it's pretty poor, so our apologies.
Pathetic. The word is pathetic. Yeah, according with the dictionary, it's pathetic, the word.
Let's go again. Has anyone of you heard about the Debian OpenSSL package bug?
How many of you?
How many?
Well, a lot.
Okay.
Will be easy. This will be easy.
So, I start with a brief introduction and some history about how the bug was introduced in OpenSSL and how it affected this package and cryptography. And then Luciano will show the most funny part, the live demo, and maybe even how to conquer the universe. So, he became a master of the universe. So, okay, this bug was caused by a Debian-specific patch introduced almost 2 years ago and remained unseen until this year, a couple of months ago, when our friend Luciano discovered this problem that affected the random number generator in OpenSSL in Debian. This bug affected not only OpenSSL but the underlying library, libssl, and every packages that linked against this library. And not only did it affect Debian distro, but any other distributions that are based on Debian, such as Ubuntu. It also affected other, or may have affected other operating systems, which are, although not based on Debian, may have imported wikis into them. So, how did it affect the random number generation? Well, in fact, the entropy got reduced to just 15 bits. So the key space, any random number generated had to be inside this very little key space of just 15 bits. Other aspects, other features we should bear in mind when that limit the key space are the platform, that is the architecture, and the endianness, little endian, big endian, 32 or 64 bits, and the length of the keys, for example, if they are 1024 or 2048. And well, these are just some examples of cryptographic schemes that got affected by this bug. As you may know, cryptography is heavily based on secure random numbers, so this bug affects all of them. These are some of the affected packages, which are linked against libssl, either dynamically or statically, and some of them were showed off in some other presentations, such as openssh and Tor. So they all relied on the security and unpredictability of the random numbers. So how did it start? It began, as I said, 2 years ago, when a Debian user submitted a wishlist severity bug to the Debian backtracking system about some uninitialized variable warning that was being printed by Valgrind. Valgrind is an online debugger that checks for memory leaks and something like that. So we show a brief demo. Sorry. we have here a program that just requests some random bytes into a buffer from OpenSSL and prints them. It's just that. So, can you hear? Yeah. We compile it and link against libssl. We see it's linked, and let's try it. It prints just random numbers. So let's see what this user was complaining about. We'll just link with the original version of this. Here. We're linking with the original version of OpenSSL, that of 2 years ago, and we're running with Valgrind just to check for any problem. So we can see here many warnings about uninitialized variables, quite a lot of errors. So this is what the user was complaining about. In fact, it affected every package that linked against libssl. So the Debian maintainer analyzed the source code and just find out that it was due to just 2 lines of the OpenSSL source code, which are these 2 lines, which are identical. They are syntactically identical, but they are in 2 different functions in different contexts. We should notice that the second line is surrounded.
Run? We should run? Okay.
So
maybe we should run.
I'm not sure.
Who pulls the fire alarm? Okay. You look calm, that's good. I am not calm. That's bad. What's happening?
They hacked our presentation.
Should we continue? What he said? Oh, he's checking. Be careful. Sorry?
So, okay, I try to continue. It's pretty hard.
Oh my God. There's people clamping, so.
The exit is over there.
Super epic fail.
It smells like sabotage.
This is not the light button, this is the alarm button. Please don't touch it. Gosh. What should we do? We can continue. Yeah, it's quite confusing. Let's stop it. Okay. Okay. If it happens again, should do something. We have water here. We can use it. Okay.
Okay. Let's go.
Ma'am, I'm okay. Are you looking at me? I'm okay.
So, okay. So these two lines are the ones to blame for these uninitialized variable warnings. But we should notice that the second line is surrounded by this macro. It's about other debugging tool, very like Bywring, that's called Purify. And this is just the original source code from OpenSSL, so that this line may get into the binary program or not, depending of the compilation options. So let's continue. There were several proposals to or solutions to this problem, but the one that looked more most suitable, thanks, was the option just to comment out these lines, because they're adding just what these lines are doing. They're in some cases they're taking this parameter, the buffer, both as input and as output. They take the input from the buffer and add it to the entropy pool. So when the buffer was uninitialized, the warning was being printed. So in fact, this entropy added by some initialized variable is almost negligible. So it looked like a good idea just to comment out these two lines. So the Debian maintainer, package maintainer, asked to the OpenSSL mailing list about these two lines, and the answer from an OpenSSL developer was that it was okay just to comment out those two lines for debugging purposes, because they didn't add any significant entropy to the entropy pool. So, okay, this is the most famous patch lately. It just commented out those two lines. But how did this affect the random number generator? You remember the function we just saw a few minutes ago? It was runBytes. When a user wants to get a random string, it calls this function runBytes with a buffer, which is both input and output. This function takes some entropy, almost negligible, from this buffer, and when the state of the random number generator hasn't been initialized, it calls the runPoll function, which takes care of this, taking or adding entropy from several sources, such as the system random device, the user ID, the process ID, and the current time. This is all through the runadd function. Finally, we got the process ID again, just in cases for multiprocess and forking, just to avoid the collisions in the random number generated. So here's the result of the commenting out the second line, that which was surrounded by the macro. We saw it doesn't add any significant entropy, so it's not a big deal. The problem relies on the first commented out line, which affected the runAdd function. So in such a way that none of these entropy sources or randomness sources were read into the entropy pool, and as a result, the only source of entropy remaining is the current process ID. This is what limits the the entropy to just 15 bits, which is the maximum process ID of the system. So we may wonder why this the second line was commented, which has this effect. Well, in fact, the Debian developer tested the OpenSSL with Valgrind, just running the OpenSSL's regression tests. And in many cases, the run add function is called directly, that is not from run byte function, for example. So in this function, which is OpenSSL API, which loads some entropy or some randomness from a file, as the comment says, there may be the case when the buffer, we're using more bytes from the buffer than those read from the file, and in this case, Valgrind would print the warning too. So, okay, so this is time to get to the funny part.
Do you get this part? The third parameter of the run add function is how much entropy is adding to a PRNG state, and as you can see, the number is only I, which means only the part have you read. So the initialized values are not taken as entropy in that case. I mean, they are valuable as 0. So that's mean that the entropy by initialization memory is negligible. That's why. So let's see. Let's see how can we take advantage of these problems. Well, as Maxi says, random numbers are everywhere in cryptography, so we will see a few scenarios where we can exploit this flaw. The first one is authentication by challenge, also known as powerless authentication. How many of you are familiar with this concept? Okay, we will be quickly in this part. Yeah, the client generates a pair of keys randomly. When the client wants to create wants to log in with a powerless authentication, the server creates a random number. They cipher with the public key. They send the challenge. The clients decipher the challenge, get again the random number, and sends to the server the challenge response. And if it's okay, access granted. Yeah. Fixed with your concept? Cool. So let's introduce another character. It's a hacker. You know, the hackers use command lines, so that's why. And this hacker uses really big fonts. I don't know why. Okay. This hacker noticed that the client generates this pair of key, these ones. I'm not sure if you can see the arrow. This one pair of key was generated by random and was generated in an unsecure Debian system. So there is a limited space for this key pair. So the attacker creates all of the possible keys, which is 2 which is 2 to power 15. And try with the first one, try with the second one, trying to respond to the challenge. Sooner or later, the servers will grant the challenge because one of that pairs will be exactly the clone that used by the client. Yeah. So this is really easy to get. I mean, it's not rocket science, but any of you didn't see this problem? Okay, let's see an example. Let's see here. Okay, HDMUR provides us a lot of the complete space for all SSH keys. It's available in his website. For example, in this case, we have the spaces for the 1024 and 2048 length. For example, for the two as you can see, it's a really small space. I mean, you can get many of these ones. Let's see how we can try it. We made a little script called exploiter, which is a really simple script. Yeah, as you can see, the script tries to, with each pair of key, tries to get login to the server. Yeah, so let's try to see how it's working. Of course, you should know the user. For example, and let's try a random server. I don't know.
WOPR?
Okay, let's go. And the port probably is 22, so let's run. Well, let's see if this works. As you can see, all the keys are the fingerprint and a number, which is the PID used for create that pair. Oh, how nice. So you know what an alarm is. You heard it. So should we run this script? I mean, push red button sounds. No.
Yeah.
Okay. Oh gosh.
The alarm.
We're still there? Yes.
We shouldn't.
Well, the script is not working well, but you can die with a bash script. I mean. Okay, let's continue with this silly thing. Okay. Well, this is the first attack. It's a really simple attack. I mean, you can literally be in a script kiddie because it's a script, so you can use it. So let's continue with the other one, but this one is really simple. I mean, let's see how to attack difficultman. How many of you are familiar with difficultman key exchange? Okay, good. So difficultman, you know about that. Yeah? Too many math for you? Okay. Both parts select random number, and after some math magic, they get a shared secret. It's something simple, I mean. Let's see, how many of you are familiar with ephemeral difficultman? Okay, I can teach you something new. No. The ephemeral difficultman is just like difficultman, but you should discard the private exponent. Yeah? So after the key exchange, you discard the private exponent. If an attacker takes control of one of the parties, he can't recalculate the shared secret. So if you want to decipher the communication, you should go against K, which of course is a really big number, so you need to brute force it. But in this case, probably you see the problem. In this case, the X, the private exponent, are random. So if those keys was generated in a vulnerable Debian system, we can look for all of them. Yeah? So let's see how this works. We just generate a list with all the possible X. We try to get the private part of one of the parties. Yeah? So if we get the private part of the client, that means that we get the X for the client. And if we can get the private part of the server, that means that we get the X of the server. Notice that even if one of the parties are vulnerable, you are able to recalculate the shared secret. That's something interesting. So we have a demo here. Okay. This is a Wireshark. Probably you are familiar with it. Maxi, me, and Paolo. Paolo is that guy who's looking for a job. If you have a job for him, please contact me. So we made a modification to the Wireshark in order to decipher a SSL and TLS connection with Diffie-Hellman, with ephemeral Diffie-Hellman. So, for example, in this case, the cipher suite was used with Diffie-Hellman ephemeral. That means DHE, Diffie-Hellman ephemeral. So, as you can see, the connection is ciphered. I didn't notice. Okay. Of course, you can decipher it because it's ciphered, of course. But if one of the part it's vulnerable, you can look for all the possibilities. So we go to preference, protocols, SSL, and this box. This is a new box was created for us. Let's see if I had the nope. This file contains all the possible X. Yeah? The all possible X can be in two lengths. Can be 64 lines or 128. 128 bits. Yeah, of course. We are talking about the length. Yeah, bits. So that's why that's this kind of lines is 2 power 16. So that's why it is. So we put this here and this here. Yep, and press OK. In this moment, we are trying to brute force the connection, looking for one of the public keys. That's why it's taking a while. In fact, looks like hanging, but it's not. It's working. Believe me. Oh, that is. So okay. And there is the connection deciphered. Thank you. Thank you.
Thank you.
Don't thanks me. Thanks, Kurt. The Kurt is the okay. It's okay. It's the guy who comments the line. Fuck. He's gonna kill me. Okay. Well, that's as you can see that this is a really big problem. I mean, you can do the same thing for SSH. So if you transfer secrets with SSH connections in the last 2 years, you should notice that you are compromised a lot. For example, if you copy your private PGP over SCP and no passphrase there was not ciphered symmetrically, in that case your PGP is compromised too. Sorry. So as you can see, it's a really big problem. Yeah. Continue. And another scenario, and this one is really, I don't know, really strange scenario, but it's really funny too. It's DSA. How many of you are familiar with DSA? Digital signature algorithms, I think. Again, sorry? Oh, many of you. Cool. Well, that's good. More math, sorry. Okay, that's as many as you know, there are many variables, public variables. There's P, G, which are primes. G is a generator. Y, it's the public part. X is the private part. And if Alice wants to sign a message M, she needs to calculate two numbers, R and S. As you can see in this part, the only purpose of R is obfuscate the X, which is the private part. Okay? And R only depends on K, which is a random number. Of course, you are seeing the problem now. If a message is signed in an unsecure environment, in a weak environment, in a vulnerable Debian, in that case, you can recover the X. You just make some math workout magic, and you can isolate the X. I'm not sure if the correct word, but you can put the X alone in one part of the equation. And of course, as you can see, S, it's a public value. K, it's a value which what we're brute forcing. The hash of M, of course, you should know it. And R is the public value, of course, Q2. So you can calculate the X, which is the private part. That means, even if DSA key pair was generating in a secure, in safe system, if that pair had been using in an unsecure system, then your pair is compromised too. Sorry again. So can you see this? No? Somebody say no? Say slower. No? Okay. Yes. Yes. We can go. Yeah. Let's go. Finish it. Okay. So we have a really good scenario here. I mean, Debian is the universal operating system, so we can conquer the universe. Yeah, as Maxi says. We can do it in 5 single steps. Of course, we should choose an application. Can be SSH, SSL, whatever. You should see what algorithm is using. For example, if an SSL connection, if you had a pickup of the last 2 years, maybe you work for the NSA and you have all the pickups in the world. That would be great in that case. It's not great. The way is not great, but you need to see which algorithm is using when in the cipher suite. Then you should generate all the possible key. That means 2 to the 15th minus 1, because OpenSSL cannot run as init, so you can save one of the keys. Times 3. Why times 3? Because there's 3 combination with Indianness and bits. I mean, Debian runs in 32 bits Little Indian, 32 bits Bigger Indian, and 64 Little Indian. I'm not sure if I said it in the correct way, but that's 3 combinations. 3 combinations. So you should generate all the keys. Of course, if we are gonna to conquer the universe, you should conquer all the platforms. So that's why you should multiply by 3. All this space can be something really easy to generate. In few hours, you can generate all the possible keys. And then you should brute force. There are many options here. You can authenticate yourself in a asymmetric, using asymmetric keys. As we see. You can contact the whitehouse.gov and try to brute force him. In this case, you need a weak public key on a server, so it's a possible situation. You can do a man-in-the-middle attack in the same way that we generate all the clones of the pairs. You can generate many clones for RSA certificate. RSA certificate. Yeah. So you can create a phishing situation or something like that. Of course, in this case you need to create a man-in-the-middle scenario. You know that is really hard. You need a multi-vendor DNS bug. You need to poison in caches. It's really hard. You didn't go to the Dan talk? Okay.
It's tomorrow.
It's new?
Tomorrow.
It's tomorrow. Oh, tomorrow is the damn talk. So that's why you are not laughing. Okay.
He was in Black Hat too.
I have news for you. Internet's gonna be exploding these days because this little problem with DNS. Where are you living? In a Tupperware? You should know this word. Okay. Let's continue. Gosh. Yeah, if you probably Dams wants to give you the surprise tomorrow. I am so stupid, but okay.
Don't tell him.
Yeah, don't tell him. Yeah, another scenario, possible scenario is the cipher connection made it with one of the part vulnerable, just as we did with Wireshark. There's many other tools you can attack SSH to. In that case, you need one of the parts outdated, which runs a Debian vulnerable in this moment. At least you capture traffic in the last 2 years. Maybe don't. There's agency that made these kind of things. I don't know. Maybe if you didn't know the Dan problem, maybe you don't know about these things. So I am noticing you. Another problem, another scenario, a possible scenario is attack cipher symmetric encryptions, storage or connections. You know, in many cases, when, for example, in a storage, if you want to cipher a storage, you create a random key which is symmetric. In that case, you need to create all the possible keys and just decipher it. It's something like that. Many backup systems are vulnerable to this flaw in that way. And of course, as we see, you can attack the DSA private part. There are tools made in this. We're gonna give you the URL in the next slides, I think. In that case, you need a message signed in a weak system. That means that the non-repudiable, I don't think it's repudiable means something for you?
Non-repudiability.
Okay, that's a strange word. Non-repudiable. The property of non-repudiable was losing in DSA. Repudiable?
Repudiability also.
Oh! Thank you, James Bond. And of course, the last step, ensure your power. Okay, there is the related work. The first one is the HDMUR tools, which has all the key spaces for SSH. You can download there. There is many length, so you don't need to calculate them. The second link is our patch for Wireshark. The third link is a Ben Snort plugin to detect communications using weak difficultman exponent in SSH. So you can get an alert if one of the parties are running weak keys. So Ben, are you here? No, he ran with the fire alarm, I think. Or maybe with the rocket issue. The third one is SSH tools. That's in that link you can find ways to decipher SSH connection when one of the parties are vulnerable. And in that link you can find a tool for get DSA private parts with a signed message in a weak environment. The Firefox SSL blacklist add-on, it's a plugin for Firefox in order to detect when you are connected with an SSH server, if the certificate is blacklisted. You need to install two extensions there. One is the extension for check itself, and the other one is the database with all the blacklisted certificates. The OpenID Debian PRNG DNS Cache Poisoning Advisory, it's from yesterday. I mean, tomorrow I think we get drunk, but we found this and we decided to put it anyway. Nowadays, since yesterday, you can't trust in OpenID anymore. Sorry. If you combine the problem with the PRNG, that means clone certificates, with the DNS cache poisoning, with the Kaminsky problem, OpenID can be fakeable. That's because OpenID doesn't use CRL, Certificate Revocation List, CRL. So, in fact, nobody uses CRL. Well, not nobody. How many of you are Windows Vista user? So you are the only one who uses it by default. Sorry. Yes, please, yes.
You're safe.
Yeah. The other ones should install by hand. But the only people who have CRL by default are the Vista users. You have other problems, but you are safe in this case. And the last link is the Debian wiki, where you can find all the packages affected and how you should regenerate the keys for each packages. Okay, so let's continue. So, some countermeasures. Of course, you should read the Debian wiki for more details, but one of the countermeasures is update libssl. Of course, if you are a Debian user, how many of you are Debian user or derivatives? Ubuntu, Kubuntu, or something like that. Okay, but probably most of you do an upgrade daily. I see some faces like, Okay, in that case, you should upgrade it. The other countermeasure is look for compromised keys. Debian provides you a nice tool to do that. Maybe I can show you. It's called SSH bull key. I don't know if you are familiar with this tool. The Debian users, you are not familiar with these tools? Okay. Well, dump up. Okay. Okay, that's good because you are learning something. So let's see. For example, in this case, there are some compromised keys here. For example, this one, which is host compromised, as you can see. There are some ones that are not blacklisted, so it's safe. This checks for your of course, this is on purpose. I'm not using compromised keys. Cool. In one of the case, it's unknown. I can't find it. Okay, but let's go on. So you know this tool now. You can write like this, and you can check all the keys on your system. Of course, you need to be root because you need to read it. Okay, let's continue. Well, you should look for weak keys even if you are not a Debian user. Maybe one of your Debian's user export to your system weak public keys. So in that case, you have a hole in your system. I mean, a really big hole. You can put a little elephant in that hole. You should regenerate all the S key if you use it in an affected Debian system. Of course, you can mitigate the problem with Firefox with the blacklist add-on. This doesn't work in all the issues, but let's leave the details. And if you are a Debian user, if you are running a SSH server in the Debian user, you can check this option in order to avoid that users with weak keys connect to your systems. Of course, all the traffic affected in the last 2 years, you can do nothing for it. I mean, the milk is already split. So let's see some repercussions. Okay, these numbers are from our friend Jürgen. Oh my God. Okay, he's German. He works in Heisek, and they make a survey with 100,000 web servers. They are looking for man-in-the-middle situations. So they detect that 3% of the servers of the people who have a signed CA are running weak certificates. This is number from 2 weeks ago, 2 weeks after publications of the advisory. So if we extrapolate this number to the global numbers, maybe to 24,000 weak certificates are running these days. Combine this with the DNS problem, and you will get a perfect phishing situation. So, another repercussions on Debian. Of course, I am the Debian developer. This problem touched my deep feelings. We get the Pony Award there. We go on the Pony Award to the most epic fail. We have it here. Say hello to the pony. There are some things that you should know before criticize us. One of these is that Debian needs to patch the systems. I mean, all the distribution patch software. That's because in most of the case, upstream has not the same goals than than the distributions. In this case, for example, for OpenSSL, it's not something big to have Valgrind problems. In Debian, this is something really huge, so that's why the problem starts. In some case, upstream is hostile. Hostile? I think the word is hostile. I mean, they are bad guys? No, not bad, bad. Not friendly. Not friendly, yeah. Well, OpenSSL guys are from the BSD school, and you know, they are not friendly guys. So, of course, we can audit all the code because it's a lot of lines of code. So, let's see. Debian is working on visibility. Do you know about the Linux law? How many of you know the Linux law? Oh. The Linux law says, given enough eyeball, all the bugs are shallow. So we are working on create many eyeballs. So we are working on visibility. So many eyeballs will see the code. In that case, we are trying to get public the version control systems for all the sources, and working on patches.debian.org, which will be a place where the patches will be there. The issue here is maybe it's not a technical problem. I mean, maybe the upstream has not an easy way to see the patches. Maybe it's a policy problem. The developers are not obliged to publish the patches. Maybe it's a social problem. Maybe we should be more friendly with our co-developers, and we should ask in better ways. And that's maybe the problem is in the conjugation of all that sets. So let's see some conclusions. We are in a hurry, as you notice. The first problem here is review twice, patch once. If the Debian developer follow the data flow problem, he will notice that the only part where buff is touching, it's there in the line in comment. So the problem is if you notice that run don't add nothing, that's a problem. So another issue is don't write fancy code. I mean, if uninitialized memory doesn't contribute with something substantial, so don't do that. Of course, make a lot of comments on your code. That will be good. Ask with details. The Debian developer just ask with few lines. You should put the context of the line. You should put what are you trying to do. If many people complain about something, maybe it's something huge. A lot of people complain about Valgrind problems in OpenSSL from many years ago. In fact, one year ago, frequency hierarchy question is why OpenSSL has a lot of warning problems in Valgrind. Of course, another big issue here is open source, and I'm activist of open source, but open source doesn't complain the Linux law conditions per se. That means open source doesn't mean a lot of eyeballs. How many of you are activists of open source? Well, many of you. Okay, so it's not enough with open source. You should see the code. So that's what that line means. Here is the thanks. And of course, we are answering question in room number
105, down this corridor, straight across the hallway.
105.
Okay.
We will listen your insults there.